What if I told you that one planet contains more than twice the mass of every other planet in our solar system combined? That planet isn't the Sun, it's Jupiter. But how did Jupiter become such an absolute giant? Why didn't Earth, Mars, or even Saturn grow that big? And here's the wild part. Jupiter might have saved your life. Let's dive into the story of how Jupiter became the king of planets. To understand why Jupiter is so massive, we need to first grasp just how enormous it really is. Jupiter is about 318 times more massive than Earth. You could fit over 1,300 Earths inside it. And yet, Jupiter is mostly made of gas. That's right, it's not a solid planet like Earth. It's a gas giant, made mostly of hydrogen and helium, the same elements that make up the Sun. In fact, Jupiter is almost like a failed star. If it were about 80 times more massive, it could have started nuclear fusion and become a second sun. So the question becomes, why did Jupiter gather so much material while everything else stayed small? To answer that, we need to go back 4.6 billion years to the birth of our solar system. At that time, there was no sun, no planets, just a giant swirling cloud of gas and dust called the solar nebula. When gravity caused this cloud to collapse, most of the material formed the sun, but the leftovers started clumping together into small chunks called planetesimals. These chunks collided, merged, and grew into planets. But here's the key detail. Not all regions of the solar system were the same. Close to the sun, it was incredibly hot. Only rocky materials could survive. Farther away, temperatures dropped enough for ice and gas to exist. And that changed everything. Jupiter formed beyond what scientists call the frost line. This is the distance from the sun where it's cold enough for water, methane, and ammonia to freeze into ice. Why does that matter? Because ice adds a lot more material. Instead of just rocky dust, Jupiter's region had rock, ice, and frozen gases. This gave it way more building blocks than planets like Earth. So Jupiter's core grew very fast, much faster than the inner planets. And once it reached a critical size, about 10 times Earth's mass, something incredible happened. At this point, Jupiter's gravity became strong enough to start pulling in huge amounts of gas from the surrounding nebula. Not just a little gas, massive envelopes of hydrogen and helium. This is called runaway gas accretion. Basically, the bigger Jupiter got, the stronger its gravity became. And the stronger its gravity, the faster it grew. It's like a snowball rolling downhill, getting bigger and faster at the same time. Meanwhile, the inner planets couldn't do this because they didn't have enough material, and solar radiation blew away lighter gases. So, while Earth stayed rocky and relatively small, Jupiter turned into a gas giant monster. Here's an interesting twist. If Jupiter kept growing, why didn't it just become a star? The answer is simple. It ran out of time and material. The solar nebula, the gas cloud, only lasted a few million years before the sun's radiation blew it away. Jupiter grew fast, but not fast enough to reach the mass needed for nuclear fusion, so it stopped just short of becoming a star, and remained the largest planet instead. Now, here's where things get really interesting. Jupiter's massive gravity doesn't just make it big, it also shapes the entire solar system. It acts like a cosmic shield. Jupiter can capture comets, deflect asteroids, and absorb impacts that might otherwise hit Earth. In fact, in 1994, a comet called Shoemaker-Levy 9 slammed into Jupiter, leaving massive scars on its atmosphere. If Jupiter weren't there, some scientists think Earth might get hit by far more dangerous objects. But there's a twist. Jupiter can also send objects toward Earth by disturbing asteroid orbits. So it's not just a protector, it's also a potential troublemaker. Jupiter didn't just grow big, it also controlled how the rest of the solar system formed. Its gravity, likely, prevented a planet from forming in the asteroid belt, influenced the orbits of Saturn, Uranus, and Neptune, and possibly even migrated closer to the Sun before moving back out. Some theories suggest Jupiter's movement may have shaped why Earth is where it is today. In other words, without Jupiter, the solar system could look completely different. So why is Jupiter so massive? Because it formed in the perfect place, at the perfect time with access to the most material. It grew quickly, captured enormous amounts of gas, and became the dominant force of our solar system. And even today, Jupiter isn't just another planet. It's a cosmic architect, a guardian, and a reminder of how powerful gravity can be. If you enjoyed this deep dive into Jupiter, hit that like button and subscribe for more space mysteries. And tell me in the comments, what should we explore next? Because the universe is full of stories, and we're just getting started.